This presentation on cloud computing with regards to telecommunication systems has been prepared by Geethan, Owen, and Frank Gustav. Let's begin with the identify stage. What is cloud computing? To commence, cloud computing is the practice of using a network of remote servers hosted on the internet to store, manage, and process data, rather than a local server or personal computer. How does it work? The cloud can be accessed via the cloud computing system's interface software. That can be as simple as using a web-based service which hosts all the applications and files that you would need for your job or personal life. The cloud is being used not only to store data, but also as an inexpensive, efficient, and flexible alternative to purchasing, running, and maintaining in-house computing equipment and software. The cloud gives you the ability to work anywhere at any time because your information is always at your fingertips. Why is cloud computing used? It is used to meet the ever-changing business needs of organizations. There is a need to invest time and budget to scale up IT infrastructures across organizations, such as hardware, software, and various IT services. However, with on-premises IT infrastructures, the scaling process can be slow, and organizations are frequently unable to achieve optimal utilization of the IT infrastructure. Organizations can simply connect to the cloud and use the available resources on a pay-per-use basis. This helps companies avoid capital expenditure on additional on-premises infrastructure, resources, and instantly scale up or scale down according to business requirements. Continuing on, let us discuss the types of cloud computing. You can deploy a cloud computing service by using three different models: a private cloud, a public cloud, or a hybrid cloud. A private cloud functions solely for one organization on a private network and is highly secure. A public cloud is owned by the cloud service provider and offers the highest level of efficiency and shared resources. A hybrid cloud is a combination of private and public deployment models. In a hybrid cloud, specific resources are run or used in a public cloud and others are run or used on premises in a private cloud. This provides increased efficiency. The cloud computing architecture is comprised of two parts, the front end and the back end, which are both connected by the internet. The front end represents the computer that you, as a client, see. This side requires you to access the cloud computing system. Gaining access can be as simple as using an internet browser, or more complex by using a unique interface software, which lets you access the cloud. The back end of a computing system is comprised of the computers, servers, and data storage systems, which store all your files and information. This is the part that does all the work. There's a central server that administers the system monitoring traffic and client demands to ensure everything runs smoothly. In addition, this central server follows a set of rules known as protocols. The central server also uses software called middleware that allows the network and computers to communicate with each other naturally. Let's discuss the type of service models. Cloud computing has three types of service models: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. The first layer is the infrastructure layer that is developed on the virtualization technology, where the service providers offer virtual machines as a service to the end users. It allows the infrastructure as a service customers to create and discard virtual machines and networks as per their business requirements. They pay for the services they have consumed. IaaS removes the necessity for the consumer to invest on procuring and operating physical servers, data storage systems, and other networking resources. By using the IaaS model, organizations get infrastructure components such as computing, power, and storage capacity. Here, the organization has total control of the entire IT infrastructure, including the hosting environment and their applications. Some IaaS services offered are Windows Azure, Google Compute Engine, and Rackspace. PaaS, Platform as a Service, is a second layer. Here, the customers do not manage the virtual servers, but rather create the applications within the programming language. They host the programs on the platform services which they pay for. The management and maintenance of the operating systems and other hardware are done by the providers. The platform as a service model provides organizations with a platform or a runtime environment to create and deploy applications. Here, the organization is only responsible for the development, maintenance, and management of the applications. Platform as a service examples are Heroku, Google App Engine, as well as Apache Stratos. Software as a service. Applications that do not need to be installed come under this layer. CRMs, email, and other office applications come under SaaS. Some services are free, while some are billed monthly or per usage. In addition, there is the hardware and virtualization layers that are owned and managed by the cloud hosting providers, and the client layer, which is the end user's hardware on which the services are delivered. The SaaS model provides organizations with ready-to-use applications that use a combination of cloud-based computing and storage services. Some examples are Google Apps as well as Microsoft Office 365. Cloud computing protocols. In cloud, everything has to be hosted on the web. Since everything is hosted on the web, certain protocols such as HTTP and HTTPS will be essential to access the services locally via REST API. Mostly, it depends upon the application which we are using in the cloud. For mail applications, we will be requiring SMTP or POP3. For the applications that require constant connectivity, we will be requiring UDP. And for those applications that require minimum usage, we will be using TCP. Overall, we will be requiring Internet Protocol or IP for accessing all the services. For VoIP and real-time applications such as online gaming, RTP and UDP protocols would be more important. This is because the latency has to be a minimum, which cannot be achieved by using TCP as a transport layer protocol. For the other types of applications that do not require real-time transfer of data, TCP will be well suited for those applications. Those applications which use the concept of windowing ensure all the packets are delivered irrespective of the latency. To understand how cloud computing can help an organization extend its IT capabilities, let us consider an example. Metrics Importers is a company that manufactures sports products. Occasionally, the research department has to store and process a large amount of data. Consequently, the company is looking for a cost-effective computing and storage solution. Additionally, Metrics Importers has a group of scientists situated at different geographical locations. The geographical barrier affects research requiring a better collaboration solution. In addition, the company is planning to develop a cost-effective data mining application to collect visitor data during its week-long worldwide annual sports event. Cloud computing provides worldwide importers with an efficient and cost-effective solution for the problems. Metrics importers can subscribe for additional computing and storage services offered by Windows Azure on a pay-per-use basis to move all of its statistical data analysis and storage to Windows Azure. By doing so, they can invest more on research. Metrics importers can use PaaS, Microsoft Live Meeting, and Microsoft SharePoint Online for efficient collaboration. For design development and testing of the data mining application, the company can use Windows Azure platform to focus on software evaluation and reduce the time and cost required for preparation of the development and testing environment. Next, let us discuss the advantages and disadvantages of cloud computing. Firstly, among the advantages, using cloud computing allows you to access your applications and data from anywhere. So long as you can link with the cloud through the internet, none of your data would be confined to a single hard drive or location. Secondly, with the movement of your files to the web, you no longer have to pay for expensive, high-memory computers. You simply need a device that is powerful enough to run the middleware needed to connect to the cloud system. Finally, the cloud computing system's backend is a network of computers you may be able to take advantage of. The network's combined processing power will speed up operations. As with any developing technology, there are disadvantages to cloud computing. Two of the biggest concerns are security and privacy. You are handing your important data over to another company to watch. Not only that, if you have the ability to log into your files and applications from anywhere, it's possible that your privacy could be compromised once the data leaves your hands and it enters the websites and cloud computing services. Cloud computing companies live and die by their reputations and reliability. Therefore, they do everything possible to secure your files, but you also need to protect yourself by having authentication techniques like complex usernames and difficult passwords. For example, an employee within Metrics might only be able to use certain applications stored on the cloud which are pertinent to work and would not be able to access higher levels. There are multiple future developments that would help solve these two main issues. Regarding data security, undoubtedly the physical security of data centers is also important, just like reliable encryption of information. In the near future, the minimum requirements for the current SSL protocol will be seriously changed. For sure, we will have to forget about the current 256 bits, as we forgot about the encryption of the 56 and 60-bit encryption. Due to constantly increasing security requirements, physical access to the data center will also be severely limited. And to enter the protected premises, you will need not only an electronic key, but also a procedure for biometric scanning. Serverless computing. With serverless computing, cloud instances are no longer allocated, only to sit idle and to called upon to fuel applications and other functions. Rather, resources are provisioned only when a specific event occurs. A textbook example of event-based computing is the Internet of Things, with sensor-based devices reacting to triggers on the fly. And when a user accesses a mobile app from his or her smartphone, an event, virtual machines in the cloud retrieve and serve up the information. Serverless, also known as Function as a Service, FaaS, represents the next leg in the cloud journey, enabling developers to focus on writing code rather than worrying about the service it will run on. Serverless makes products more both reliable and scalable. This renders moot the problem of idle instances. Instead, when a predefined event occurs, code written specifically to execute a function is triggered, and the serverless platform performs the task. Customers don't need to tell the cloud vendor how many times these functions will be triggered, and they pay for a fraction of the penny every time a function is executed. At the moment, people are restricting themselves to one service provider, usually because the process of getting started with a new provider is painful. But a serverless architecture, it means being able to move between providers, and this will be a change that comes around quickly. Explosion of information across industries as well as consumers is no longer a phenomenon that surprises us, but rather the scale of it keeps getting bigger. Just to sample a few numbers, 120 hours of video are uploaded to YouTube every minute, every day. More than 200 million emails are exchanged every minute, and a server has to be activated every 10 seconds to support new smartphones. We are on the brink of a revolution. Cloud computing is everywhere, with tools like Google Drive replacing Microsoft Office, banking websites replacing branch offices, and Dropbox storing all of our data. Cloud computing is now ready to take over.